We are Tokyo team, Kawazue Lab, the University of Tokyo. 11 members of the Kawazue Lab were divided into 3 teams to analyze the nightscape of Tokyo. First, we are going to take a look at Japan in the world. Electricity consumption per capita is the 4th largest in the world. We will also see that while power consumption in Asia is growing, Japan's power consumption hasn't changed so much. Next, we are going to look at Tokyo within Japan. The 3 largest cities in Japan are Tokyo, Osaka, and Kanagawa. And Tokyo ranks first in a variety of categories, including population and electricity consumption. From this, we can see that over-concentration in Tokyo is occurring. Next, we will look at what the night view of Tokyo consists of from the satellite image of Tokyo at night. The areas highlighted in yellow are the commercial areas, and the areas highlighted in orange are the industrial areas. You can see that these areas are light at night. The area highlighted in purple indicates residential areas. You can see that residential areas are relatively dark. We have chosen Nishinjuku office area, Shibuya commercial area, and Sangenjaya residential area as survey sites, and we tried to analyze the Tokyo nightscape through these 3 cities. We will show you a little more about what the 3 cities are like in terms of the degree of urban maturity. First, the center of the city is created by the stations or according to the terrain. Next, from the center of the city, streets are formed such as shopping streets. Then the center of the city grows and various roads are formed. The 3 cities mentioned earlier should be divided into these categories. We tried to clarify what the night view of Tokyo is like by looking at the night view of these 3 cities from 3 perspectives: color for Team 1, height for Team 2, and creativity for Team 3. We walked around these 3 cities and looked for the heroes and villains of each city. Shibuya is a commercial city and is characterized by lights for different purposes. The districts are constructed of different characteristics, divided into 3 categories: excite, calm, flow. Let's take a look at a game about finding heroes and villains. The heroes and villains we collected in this way are shown here. We categorized the photos based on the 3 indicators. In Shibuya, colorful signs create a lively and exciting atmosphere, while the unique and soothing new lighting creates a peaceful atmosphere. It's such a complex city. Nishinjuku is a city of tall office buildings and is characterized by the nightscape of those lights through windows. The buildings are far beyond human scale. Various elements appear to overlap as a landscape in the eyes of people. These are the heroes and villains in Shinjuku. And we also categorized these photos in the 3 indicators. Shinjuku gives a cold impression, but there are also beautiful scenes created by the reflection, overlapping of trees, and low-rise spaces that are warmly designed. Sangenjaya is a residential area. Because it's a small city, each light is set up with its own intention. The small district is of simple urban tissue of shopping streets and residential areas by developers, shop owners, and residents. These are heroes and villains in Sangenjaya, and we also categorize these photos in the 3 indicators. There are a lot of warm lights in Sangenjaya, creating a soft light environment for residents here. However, in some shopping areas, many powerful lamps destroy the nightscape.
Here we will focus on the colors and try to evaluate the night well. Color has 3 attributes: hue, value, and saturation. Before analyzing the color, only the parts with certain brightness was extracted in a photo. This is because if you analyze the color as it is, the resulting analysis value may be different from the impression you see with the naked eye. To avoid that, we extracted only the part with constant brightness and analyzed only that part. The values of the 3 attributes, hue, brightness, and saturation of the color were calculated using analysis software. In this image, we also conducted an experiment. The image of the night well is displayed on the monitor to the subject. Then psychological data is acquired by measuring the brainwaves of the subject while watching it. From the brainwaves, you can see how much the subject is meditating and how active it is. Furthermore, after seeing the image, we will conduct a questionnaire survey by the ISD method and acquire subjective data such as like or dislike. A total of 15 photos are shown to the subject. The photos were taken in 3 areas of Tokyo as we introduced earlier, and we selected 5 of each that will well represent the characteristics of each area. In order to more clearly show the data, we named the 15 photos as photos. Shibuya is A, Nishi Shinjuku is B, Sangenjaya is C. This is an example of measuring the brain waves of subject. The graph on the right shows the degree of meditation obtained from the subject's EEG measurement. The x-axis of the graph shows each photo from AE to C5, and the y-axis shows the degree of relaxation of the subject for each photo. This subject can be seen in the B5 image to be the most meditating. This is a chart we made to illustrate the meditation result. we try to calculate the average value of the meditation values of all the subjects. Then the characteristics were seen in each region. The yellow part represents Shibuya, the blue part represents Nishi-Shinjuku, and the green part represents Sangenjaya. Shibuya is the median value on average. Nishi-Shinjuku has a high value on average. Sangenjaya has a big difference for each photo. So what is the cause of the regional differences in EEG data? We approach it from two sides. The first is the color of the image. This uses the color analysis data explained earlier. The second is the subjective evaluation of the subject's image, which uses the experimental questionnaire survey by the SD method. Let's take a closer look at the relationship between the first color and brain waves. The number displayed here are the percentage of red and green in the image analyzed by the software. In order to find the characteristics of each region, the ratio of red and green in the image was totaled for each region, then compare it with the graph showing the degree of concentration. Then it was found that the graph with more red activates the brain and the one with more green can meditate the brain. Next, we will explore the relationship between the second subjective evaluation by the SD method. This is an average of the results of the questionnaire of all the subjects. You can see the average of the subject evaluation of the subject for each region. The x-axis shows the atom in the questionnaire, and the y-axis shows the degrees to which the subject feels, such as very or a little for the atom. This graph is structured so that positive evaluations are distributed in the upward direction of the y-axis and the negative evaluations are distributed in the downward direction. Shibuya is a colorful downtown area, and light sources of various hues are distributed. As a result, we are receiving positive evaluations such as lively. It also causes negative evaluations such as tired, not calm, and unsettled. Nishi-Shinjuku is an office district. The properties of the light source are uniform with little variation. As a result, we are receiving positive evaluations such as cool and elegant. They also cause negative evaluations such as lonely and unactive. Now pay attention to the atom, lively and quiet. This was highly evaluated by region. From the graph, you can read that the result that Shibuya is ahead, then Sangenjaya, and then it goes down definitely to Nishi-Shinjuku from negative evaluations such as lonely and unactive. Let's compare this result with brain waves. In the lower left, the ranking of queerness by the SD method and the ranking of meditation by EEG measurement are written. You can see that the two match. From this, it can be seen that the greater the impression of the requirement of the image, the more the brain meditates.
The second perspective is height. Does the height change how you feel about the night view? Firstly, we selected a place to represent each area. Then we found a building over 100 meters in each chosen place and took a picture every 20 meters from 0 meters to 100 meters. So we took 6 pictures in each area, you can see different views of city as height changes. For these pictures, we did two kinds of analysis. The first one is image analysis to show objective evaluation. We measured luminance and contours of pictures. We also analyzed the total area, average size, and number of highlights. The second is the SD method, a semantic differential method to see subjective evaluation of us. The subjects are asked to evaluate each picture based on 7 pairs of adjectives into 7 grades. From these analyses, we have made line charts representing relationships between height and each element. We try to find out correlations between chart objective evaluation and subjective evaluation of the SD method, so that we can find out which element obviously affects our psychological evaluation. Let's see the results of our study. We made images with different colors depending on the brightness. How does luminance change as the height increases? We compared these results with the results of the SD method and found some correlations. Shibuya is correlated with dynamism, clearness, glare, and brightness. Nishishinjuku is correlated with likability, safety, and dynamism. Sangenjaya is correlated with glare, total area of highlights. We did research on the total area of highlights. How does the total area of highlights change as the height increases? Shibuya is correlated with dynamism and clearness. Nishinjuku is correlated with dynamism, clearness, safety, likability, glare, and comfort. Sangenjaya is correlated with glare. Average size of highlights. We also analyzed the size of highlights by dividing it into several types. How does the average size of highlights change as the height increases? Shibuya is correlated with dynamism. Nishishinjuku has no obvious correlation. Sangenjaya is correlated with comfort and glare. Number of highlights. We counted the number of highlights. How does the number of highlights change as the height increases? Shibuya is correlated with dynamism, brightness, clearness, and glare. Nishinjuku is correlated with safety, dynamism, likability, clearness, comfort, glare, and brightness. Sangenjaya is correlated with dynamism, contour. We extracted the outline of the lights. How complicated is it as the height increases? Shibuya is correlated with dynamism, clearness, brightness, and glare. Nishinjuku is correlated with dynamism, likability, safety, clearness, glare, brightness, and comfort. Sangenjaya is correlated with brightness, clearness, and glare. Conclusion. Shibuya, as the height increases, luminance, the average size and the total area of highlights decrease. Luminance, length of contour, and number of highlights are closely correlated with dynamism. Besides, luminance is also closely correlated with clearness and glare. Total area of highlights is correlated with both clearness and dynamism. There is no significant change with height in the evaluation of safety, comfort, and likability. Nishinjuku. As the height increases, highlights become smaller and the number of highlights increases. Luminance is correlated with dynamism. Total area of highlights is correlated with dynamism, clearness, glare, and brightness. Number of highlights and contour are correlated with dynamism, clearness, glare, and brightness. Comfort, likability, and safety are correlated with total area of highlights, number of highlights, and control. Sangenjaya. As the height increases, the number of lights increases and the average size of lights decreases. Luminance, total area of highlights, and average size of highlights are correlated with glare. Total area of highlights is correlated with glare and clearness. Number of highlights is correlated with dynamism. Comfort and likability increase with increasing darkness and reach a maximum at 80 meters. For the three pairs of most subjective adjective words in our testing method, likability, comfort, safety, the overall relationship with height is as follows. About Shibuya, there is no obvious psychological change in likability, comfort, and safety according to the height of view. About Nishi-Shinjuku, the psychological evaluation is correlated with the number of highlights and the contour. So the higher the height is, the better the psychological evaluation will be. About Sangenjaya, it is not clear which factors are obviously related to psychological evaluation. The average size of highlights is slightly correlated with comfort, and the evaluation at 80 meters is the highest.
This is the last experiment. Let's talk about the creativity. A night well relaxes us, but can it increase our creativity? Let's start with the purpose of the experiment. In order to clarify the relationship between nightscapes and creativity, we will use brainwaves to verify the results. Let's take a closer look. The subject will be repeated in 3 images. And the subjects have to complete the creative task. Now let me show you the images used in the experiment along with the locations where they were taken. The first one is Shibuya. The day and night images were taken at the same angle. Next is Nishi-Shinjuku. Finally, Sangenjaya. As you can see, we took 6 photos from buildings in 3 different areas. Now you may be wondering how we measure creativity, right? We used the test called the AUT, which asks the participants to think about as many unusual ways to use an object as possible. For example, here 4 possible uses for a cup are listed up. There are 2 iteration methods. One is fluency, which is the number of ideas, and the other is flexibility, which is the number of different ideas, with similar ideas content as one category. Looking at the example of the cup, fluency is worth 4 pounds, but flexibility is worth 2 pounds, excluding coverages. Now let's see the actual experiment. We look at the image like this and measure the brainwaves at the time. Here, the values of attention and meditation are derived based on this. After that, the subject starts the text. In this way, we can know the relationship between brainwaves and test performance during image building. So what kind of results did we get? Now let's see the results. First, let me show you brainwaves results. This shows the values of attention and meditation during watching each image. As you can see, meditation was higher at night in all 3 regions. On the other hand, attention was lower at night in Shibuya and Shinjuku, and higher only in Sangenjaya. From these results, we can see that the nightscapes tend to make you more relaxed and less attentive. Next is creativity tests. This shows the fluency and flexibility scores of each image. In Shibuya and Shinjuku, both fluency and flexibility were higher at night. But in Sangenjaya, they were lower at night. Comparing these results, we can guess that being more relaxed and less attentive enhances your creativity. In addition, we look at the increased ratio of brainwave values during watching images. We identify the most and the least increased images. Then comparison with creativity scores, you can see that there may be a relationship between attention and fluency, and between meditation and flexibility. It means that when you are concentrating on something, you can come up with many ideas. And when relaxed, you may be flexible and come up with various ideas. Finally, we consider the differences between those three areas from the perspective of creativity. As we've already seen, only Sangenjaya didn't enhance your creativity. Comparing these images, variety, noticeability, brightness, density, etc. can be considered as the cause of the differences. In conclusion, we can see night view tend to make you more creative than daytime view. However, to enhance your creativity by nightscapes, some variety of brightness, etc. is needed. We researched the night view of 3 cities in Tokyo from 3 different perspectives. It turned out that each city had different characteristics in color and brightness, and it affected our physiological and psychological reaction. And it even affects our creativity.